Module 2 examines the foundation of shoreline cleanup assessment techniques by explaining SCAT's mission, definitions, principles, benefits, and deliverables. It also sets the context for SCAT application, such as local to national response capacity building under a tiered response, getting ahead of operations, understanding the dynamics of establishing a primary and representative SCAT field team, and then we look at its histories and evolution. This module takes about 20 minutes to complete.
There needs a firm understanding of the SCAT definition and its deliverables. Let's begin with its definition. The Shoreline Cleanup Assessment Techniques, otherwise known as SCAT, process is a systematic and comprehensive approach that incorporates experience, science, and local knowledge during an oil spill to provide timely information on shoreline oiling conditions. In doing so, it has deliverables. SCAT generates information on a shore and its oiling conditions that is evaluated by an incident management team as they collaboratively decide and agree on appropriate course of action regarding a shore's treatment, method, level of effort, and completion, otherwise known as its endpoint for its final closure. Both the SCAT process and its people can have a very high profile during a marine oil spill. You are being observed and evaluated. That's because one can't hide stranded oil, and there is a high expectation to show something being done about it. Expectations and reality can clash. SCAT needs to find the correct balance and foster hope and confidence for a coastal community that life will get back to normal again. It is difficult to fully pre-plan shore cleanup from an oil spill owing to the complexities of such factors during an incident as what type of oil is spilled and its volume, where it spreads, how it weathers, the type of shore it oils, the remoteness of location, and more. Then having to address each shore's sensitivity and diverse coastal values and ecologies, and finally, what cleanup methods to use, if any. It's a complex subject. Establishing SCAT capability and capacity from local community to national levels helps rise to these challenges. It's also by being versed in SCAT established a strong foundation to be flexible, nimble, and practical when the time comes to be engaged. It's important to get ahead of the curve during the onset of an environmental emergency, such as an oil spill. As oil approaches shore, there needs assessment and operational readiness to respond rapidly, to alter offshore oil tactics, to recover mobile oil trapped along near shore before it strands, to remove heavy concentrations of fresh shore-stranded oil before it remobilizes, and to deal with shore-stranded oil before it weathers and or becomes covered with sediments. These are time-sensitive factors that SCAT members need to recognize and account for. It is important to get ahead of the curve and begin the SCAT process and start building a shore protection program that includes being engaged in area reconnaissance, creating an organization, addressing the logistics of getting SCAT people in their field, addressing mobile oil trapped near shores before it strands, and establishing a generic plan to get operations going, and more. At the onset of an oil spill, it is common for response to focus just on recovery of floating oil, leaving any near or onshore oil management operations for later considerations. Therefore, it's a challenge for SCAT members and others, those engaged in shoreline response, to get attention and shift tactics at the same time. But it is important to do so. This is an example of the institutional aspects of SCAT. Delay in establishing a SCAT or shore protection program can result in exponential costs and ecological damages. An outcome can be months to years of cleanup operations. As such, the SCAT process and products provides an opportunity to mitigate long-term environmental impacts to shores. Let's look at SCAT capacity development. SCAT preparedness and delivery can be established at local to national levels by industry, agencies, and First Nations. This is because an environmental emergency builds from the bottom up, beginning with the local community who will respond first. Other agencies and their contractors arriving on scene when and where needed to augment and build the response capacity and capability. This process is referred to as a tiered response based on resources, people, equipment, technologies from local, regional, national, and international sources. Take a close look at the chart. You will see that a local community, such as a First Nations band or council, has a lot to benefit from being immersed in SCAT because of their local knowledge, logistical support, coastal values, and more. Tiered-based planning to build response capacity helps focus efforts and resources in an optimal way. Implementing SCAT processes follows similar steps as for other oil spill response actions, such as done by local community governments that includes, but not limited to, undertaking field observations to know where the spilled product is spreading, invoking geographic response strategies they have developed so as to deploy nearshore protection booms, establishing incident management under the incident command system, and then offering logistical services to incoming personnel from agencies and contractors, such as their facilities and vessels. These actions build on the concept of tiered response, starting with an oil spill impacting or threatening a coastal community comprised of a local government's district or a First Nations territory. It is these governments that either are aware of the incident or have been notified about it. They can participate at the command table with their assigned incident commanders to jointly manage the event with other agencies and the responsible party. Now that we've explored why and where SCAT fits within oil spill preparedness, let's begin to look at its missions, purpose, benefits, principles, and dynamics. The mission of SCAT is complex interaction that often results in trade-offs on what can or cannot be undertaken to clean oil shores. The mission statement goes like this. It's to maximize the recovery of oiled environments and resources while minimizing the risk of further ecological injury from the cleanup efforts. The mission of SCAT is achieved by striving for environmentally sound and cost-effective response activities to achieve an overall net environmental benefit. The concept of net environmental benefit is looked at more fully in the next module. SCAT, when delivered in a timely, practical, and collaborative way, has a very defined purpose for everyone with a stake in the outcome of an oil spill. This is because SCAT offers decision-making support for treatment, planning, and operations for each segment of oiled shores. SCAT provides assessments of shore stranded oil with a focus on the shore's geomorphological features, operational limitations, ecological resources, human uses, and cultural sensitivities. The SCAT field data and its analysis assist in determining priorities for cleanup for oiled shore segments, objectives and strategies for shore-based operations, the logistics, the people and equipment requirements, the constraints or what not to do for cleanup operations, monitoring the effectiveness of cleanup efforts. It is instrumental in determining the levels and types of oily waste generated, and most importantly, it determines the completion of a shoreline's cleanup efforts, the endpoints, that brings closure and sign-off for each shore segment oiled. For each purpose, there are benefits. The SCAT benefits include ensures field information has been collected and documented, expedites decisions on priorities for cleanup and its the methods, and when adequate mitigation has been achieved, reduces response costs, mitigates secondary environmental impacts, lessens the amount of oily waste generated, and then, most importantly, fosters agency, industry, First Nations, and stakeholder confidence, trust, and acceptance on spill response performance. The core SCAT principle is to assess and measure oiling conditions on shorelines within the envelope of its trajectory and spread, and then communicate to operations and to incident managers. The field of information has to fit within the incident management's established timelines and action plans. In doing so, the SCAT process uses standardized references, procedures, and terminology for documenting field information and for communicating the results to the incident management team residing at an incident command post, as well as to operational personnel working on all its shores. A SCAT goal is for field data to be timely, consistent, comparable, scientific, and useful. SCAT is a very dynamic, interactive engagement process. Within the dynamics of an oil spill, SCAT brings the field perspective to the incident management team. This includes oiling conditions for each shore segment. This is followed by agency, First Nation, and responsible party collaborations on treatment measures, if any, and levels of clean, the endpoints. The agreed course of actions are then communicated to shoreline operations to be undertaken. As such, SCAT dynamics includes fostering a technical and social contract with all parties on when and what will be accomplished for each segment of oiled shore. For an oil spills management, it is important to understand and differentiate the roles of governments and the responsible party. The responsible party, often referred to by the acronym RP, can be a ship owner who is responsible for impact mitigation, such as recovering on-water oil and cleaning oiled shores. The word responsible doesn't infer fault for the pollution and damages. That matter is determined by the court of law. It is generally understood by the response community that is government, inclusive of affected First Nations, as the steward or trustees of natural resources, the shorelines, fish, birds, mammals, cultural resources, who are responsible for establishing environmental protection priorities during an oil spill. On the other hand, the responsible party, with its response contractors, is primarily responsible for the tactical operations of spill response, as well as ancillary activities such as to support SCAT fieldwork. They may even hire you as one of their technical specialists after you've taken this course. SCAT can be defined by 3 F's: function, flexibility, and facilitates. It works within the incident command system. It's scalable to all sizes and types of oil spills and addresses representatives and stakeholder interests. It can be adapted to ocean debris, such as container vessel accident that results in a widespread debris field on shore. An essential aspect of SCAT is that its process work on a shore-by-shore basis to ensure each oil shore is given full consideration. This requires the coastal shorelines within the envelope of an oil's trajectory to be segmented according to each shore's geomorphology, such as if it's a sandy beach or a rocky headland. Take a look at the map for shoreline types. Each shore is given a unique identification number. These shore segment numbers are then used for mapping oiling conditions, determining best practices, what the endpoints will be, manage assignments, and track progress, and more. If there's no coastal shoreline segmentation, it is one of the first steps that a SCAT coordinator to undertake. The roots of the SCAT process could go back to the early 1970s when the oil tanker Arrow ran aground in Chedabucto Bay in Nova Scotia, Canada. It spilled the bunker sea oil that was being carried as cargo, resulting in one of the most significant oil spills in Canada due to extensive oiling of shorelines. The process became refined during the 1989 Exxon Valdez tanker spill in Alaska. The agency custodians of SCAT in the United States and Canada are the U.S. National Ocean and Atmospheric Administration and Environment Canada and Climate Change, respectively. SCAT is also used internationally, such as in the United Kingdom, Australia, and New Zealand. Worldwide, the principles of SCAT are the same, only the working environments, ecologies, and social values of old shores differ. SCAT continues to evolve from a technical standpoint and has become adopted worldwide. It doesn't matter where you are in the world, its mission, principles, purpose, and benefits remain essentially the same. For example, in Canada, the first edition of Canada's SCAT manual was published by Environment Canada in 1992, then revised in 2000, and the third edition was written in 2018. There is actually an overwhelming amount of operational guidelines and job aids and technical scientific references related to SCAT. This course tries to boil it all down to a usable and understandable topic. As mentioned already, there are numerous operational guidelines and job aids to reference. Some provide good concept overviews, while others delve into technical details. This course essentially follows the third edition of Environment Canada Climate Change's Shoreline Cleanup Assessment Technique Manual, revised in 2018. SCAT has achieved the gold standard of being recognized as the industrial standard by the American Society of Testing Materials. It is necessary to acknowledge Ed Owens, living in Bainbridge Island, state of Washington, United States. He is the pioneer in SCAT development, beginning with post-Exxon Valdez oil tanker incident in Alaska, and continues to consult in this field. I have taken many courses with him since 1990s and stayed abreast of his guidelines, scientific papers, and workshops ever since. Ed Owens is the world's SCAT guru.